But first, let me start by saying that my name is Michelle Nal. I will be teaching the level 2 and some of level 1 courses during the summer. I also teach 401, 500, and 501 during the school year. And in the past, I coach teams in Mathcounts, or I prepare students for other math competitions such as AIME 10, AIME 12, or AIME level. I'm going to talk about the summer level 2 course. I used to be I was in Texas, but recently I moved to Virginia. And our summer courses, we have online, and we have for certainly for level 2, it is going to be in person for the last 2 weeks in June. For those who can attend the in-person courses, I would recommend also doing that if you can. And for our online courses, we will have different dates for the online sections. In person, we just have one session, which is at the end of June, for the last 2 weeks in June. Level 2 classes cover questions similar to earlier AIME problems and later AIME 10. When I say later AIME 10, I mean somewhere from like AIME 21 through 25, and AIME probably 3 through 10, maybe some earlier AIME 11s and so on. And the level 2, we introduce the topic for, depending on the topic, between 20 to 45 minutes. Then we go over the questions with the students. Because the level is a little higher than obviously the level 1 or the intro, so the questions, we do not solve as many problems because each question takes longer time, obviously, to execute and to motivate students and so on. So it is a 3-hour session in the morning and 3 hours in the afternoon. And but we give a break at the end of each hour, about a 5 to 7 minute break. Like I said, we do not solve, it's not very efficient to solve 30 problems or so, but we do cover somewhere between 15 to 20 problems in each class. Like I said, because the questions level is higher, the solutions takes a little longer. We encourage students to ask questions via chat, or they can unmute themselves and ask questions. So please feel free to do the same today. Like I said, the questions I'm solving today are not going to be repeating in the summer class. This is just to give you an idea of how we cover the class and what type of questions we solve during the level 2 sessions. Okay. So today, the topic is trigonometry, and we are going to cover the basics, and we are going to prove some of the formulas. Like I said, anytime if you have a question, feel free to unmute yourself, or you can use the chat box, okay, whichever you feel comfortable with. Okay. And so we use trigonometry to solve some algebra questions and also geometry. But we mainly covered trigonometry in level 2 to focus on the geometry problems. But to do that, we first start going over the basics and going over the trigonometric identities, and then we move on to the geometry part of the section. But today I will be covering the trigonometric identities, and but usually the sequence is again formulas, identities, and using trigonometry in geometry. And then in level 3, they use we do algebraic equations using trigonometric functions as well. And so we're gonna start here. Now, so we have, for an angle theta, where theta is between 0 and 90, we define functions to describe the size of the angle. Basically, trigonometric functions give us the ratios. Right? Okay, and if we have raised O and A, so let's say we do have, okay, and so this is theta, and here is O, A, and B. if we choose a point P on ray, and if we draw the altitude on OB, right, and then where it's perpendicular, where when we draw it, where PQ is perpendicular to OB. So we have P and then Q here. Then we can define the sine, tangent, cotangent, cosecant, and secant functions as follows. So we say that sine theta is opposites over the hypotenuse. Cosine theta is adjacent over the hypotenuse. Tangent theta is opposites over adjacent, and then cotangent theta is 1 over tangent, which means it is adjacent over opposite. Cosecant is same as 1 over sine theta, and secant theta is same as 1 over cosine theta. And we can say that these functions are well defined, meaning that it doesn't depend. Well defined means it does not depend on the size of the PQ or OA or OB. And we can show that by simply changing the size. For example, you're going to use similarity here. Sorry about that. So when we use similarity and when we draw, let's extend this. Sorry, everyone. If we extend this, and if I draw line here, let's call this P prime and Q prime, right? We can see that, for example, we can write that sine theta is equal to P prime Q prime over OP prime, right? But you can see that, well, although this looks different, but we know that these two are the ratios, right? Okay, and by similarity, we know that PQ is parallel to P prime Q prime, and we can say that because these are parallel, we can write this, and then that means OPQ is similar to OP prime Q prime. Okay, and since it's similar, we can write the ratio. We know that PQ over OP is going to be same as P prime Q prime over OP prime. And since these ratios are the same, we can say that these functions are well defined. Like I said, meaning that it does not depend, it doesn't depend on the size of the PQ or P prime Q prime. Okay, very good. These ones, obviously, this is something we have to memorize. This is probably the part that people find it hard to do, but memorizing the trigonometric identities or formulas. But there is some that, but in this topic, it's something that we have to memorize. Okay? We are going to derive some of the formulas, but since we cannot, I mean, during the contest, you don't have time to derive these, so we need to memorize them. Okay? So now, obviously, we use this in a triangle, right? So when you have a right triangle, then we can say that sine A. Okay, so let's use it here. So we know that sine A, angle A here, is equal to, again, remember what we said? It is opposite over the hypotenuse. So it is A over C. And then we know that cosine A is equal to B over C. Okay. Now, obviously, by Pythagorean theorem, we know that A squared plus B squared is C squared. Now, let's keep that in mind. So if I write sine square A plus cosine square A, it is simply A squared over C squared plus B squared over C squared. So it is equal to A squared plus B squared over C squared. Because of the Pythagorean theorem, we get C squared over C squared, so that's 1. And we know that this is one of the first identity that's to memorize, if you don't know it. Okay? So sine square A plus cosine square is equal to 1. Same thing if you use the angle B always, right? Are we good? Any questions here? Okay, now let's move on to what we're going to do is, now let's move on to finding another identity by using the identity that we just found. Okay. Remember, so we found that sine square A plus cosine square A is equal to 1. Now, if I divide both sides by, let's say I can divide both sides by sine square A, or we can do cosine square A. Okay, we can do both. Let's first start dividing by cosine square A. If we divide everything by that, then we get, and then obviously this equals 1 over cos squared. Now, we know that sine over cosine is tangent. So this is tangent square A. Cosine plus divided by cosine is 1. And then 1 over cosine is secant squared. So this is another identity. If we divide this by cotangent square, then we get that, if we divide this equation here by sine square A, then we get cotangent square A plus 1 is equal to cosecant square A. This is another identity that you know. Again, so far, so we have 3 identities, 1, 2, and 3, and we are going to use these identities quite frequently. Now, we know the values of the special angle, right? We know that there are special right triangles 30, 60, 90, and 45, 45, 90. Now, using the right triangle here, so we can say that if let's say if our angle is 45, then we know that sine 45, okay, let me draw this really quickly here. Oops, let me draw it a little bigger, obviously. Remember, with the 45 here, we have A, B, C, 1, 1, root 2. And I remember we have another special right triangle here. Obviously, we have 1, root 3, and 2. Okay. Now, using this, we can find the values for 0. I will give you the zeros for 0, 45, 30. I forgot the 30. 30, 45, and 60, and then 90, right? Okay. Now we can find the sine and cosine values. Okay. If you make this table here really quickly, then we can write the values. Sine 0 is 0, cosine 0 is 1. Sine 30, remember sine is opposite over hypotenuse. So this is 1/2. Then cosine is root 3 over 2. This one is, if you look at here, it's 1 over root 2, or we can say root 2 over 2. Here is root 2 over 2 as well. And then root 3 over 2, 1/2, and then 1 and 0. Okay. We can find the tangent and cotangent. Tangent is sine over cosine, right? So the tangent value is going to be what? 0 here, 1 over root 3, 1, root 3, and undefined. And cotangent will be 1 over tangent. As you can, okay, we cover the unit circle parts for sine and cosine in the second part of the trick when we, before we talk about the geometry. Are we good? But just for those who are interested, we can actually cover it. Sorry, guys. We can actually cover it right here. So if I have let me draw the unit circle here. Everyone knows what a unit circle is, right? It is because I don't know if there are parents or students here, so I'm not asking you guys questions, but during the class, I call students by name and I ask them the questions, okay? This is not to test you, but just to make sure that everyone is participating and it is a more interactive class. Now, when we unit circle, we know that the radius is 1, right? The vertical axis is the sine, and then the horizontal is cosine. Now, we know that, let's say this is also a radius, so it's 1, right? So let's call this angle 30. Therefore, we can find the length here, right? Because the radius is 1, now we know that the side across from 30 is root 3 over 2, and here is 1/2. So we found the sine 30 and cosine 30 values, right? Okay. Same thing over here. For example, if I draw, let's draw this one here. Let's call this is 30. So obviously this is 150, right? And then we can find the corresponding values here as well, right? So you know that here is 1, and we know that this is root 3 over 2, and here is 1/2. Okay. So one thing you notice here is this, right? So we know that, let's say the cosine value is root 3 over 2, sine value is 1/2. Okay. And then in here, cosine value this time is what? Negative. So sine is still positive. Okay. And notice that these are almost the same, except the cosine is negative on the second quadrant. So in the first quadrant, they are both positive. Cosine is negative, sine is positive. Both negative, sine is negative, cosine is positive. Okay. And we can see that here, the values are going to repeat every 360, right? We sometimes use, so this is in the, I use the decrease version. We also use it in radians, right? Radians means basically the whole thing is 360. We call it, what is the circumference of this is 2 pi, right? So 2 pi is equal to 360 degrees. So pi is 180. So if they ask you what is sine pi over 6, this means this is sine 30. Okay. Usually in the trig problems, they give us a range. They are telling us that, let's say the angle x is between 0 and pi. This means sine cannot be negative in this region, right? Okay. So we need to pay attention the interval that the question is given. And notice that by looking at here, we can see that the largest value sine can take is 1. Smallest one is -1. Same is cosine. So sine x can only be between, sorry, not 0, -1 and 1. Same as cosine x, -1 and 1. But there's nothing like that in tangent, right? The tangent function looks something like this. So it goes from -∞ to ∞. Okay. But if you find a sine value or cosine value that is not within this range, that means there was something wrong with the solution. Okay. Any questions here? Please let me know if you have any questions. Okay, so let's go on. Let's take a look at this example here. On the example here, we are given that BCA is at 90 degrees, okay, and D is the perpendicular, CD is perpendicular to line hypotenuse AB, and then AB is given as X, and angle A is theta. We are going to find all the line segments, meaning AC, BC, BD, AD, and CD, in terms of X and in terms of theta. Now let's start, because we know that here is angle theta here. Let's use the big triangle ABC, and then let's write all the, let's start with finding the line segments for AC and BC on the big triangle. Okay. Now, let's start with sine theta here, right? We know that sine theta is BC, which is the opposite over hypotenuse, AB. Okay. And from here, I know that AB is X, by the way. I know that BC is AB times sine theta. So AB is X, so BC is X times sine theta. So we found BC. Now, similarly, cosine theta is AC over AB. So therefore, AC is equal to X times cosine theta. So here's the next one. Okay. Very good. Now, these are, we said, well, how are we going to write these ones, right? So let's see here. Let's do a little bit of angle chasing to find the theta, right? So here you know that because ADC is a right triangle, here is 90 minus theta. I know that now because ACB is 90 degrees, then DCB is theta. Therefore, the angle DBC is 90 minus theta as well. We can also find it from the big triangle. Okay. I hope Makes sense. So far, I know AC, BC, and obviously AB is given. So using the triangle ABC, let's figure out the length AD and CD. So let's use triangle ABC. Now, on triangle ABC, remember, I know the side length AC, right? Which is the x times cosine theta. Let me write it there for now. Okay. So we know that again, x cosine theta. Now, we can write, let's write sine theta again on triangle AC. We know that sine theta is equal to CD over AC. So from here, I know that AC was x times cosine theta. So we have x cos theta times sine theta. So we are done with CD. Now, let's find AD, right? And we can express AD because we wrote sine D is across from CD. So now let's write cosine theta. So we know that cosine theta is going to be equal to AD over AC. So now we know that AD is, again, AC was x cosine theta, right? So it is x times cos squared theta. Okay. Now we are done with the only thing that is left, BD. So we're going to use triangle BCD. Triangle BCD. Now I know that sine theta here is equal to BD over BC. Remember, we found BC in the first one, it was x times sine theta, right? So therefore, we know that BD is equal to x sine theta times another sine theta, which is sine squared theta. And this was BD. Okay. So we found it all, right? We found BC, AC, CD, AD, and BD. I hope that makes sense. Now, obviously, you can also use 90 minus theta, but let's take a look at here. Take a look at the big triangle. On the big triangle, remember, we said that sine theta was BC over AB. Now, if I write sine 90 minus theta, which is going to be equal to what? AC over AB. But remember, we found that was cosine theta as well, right? So one thing that is important, if two angles are complementary, their sine and cosine values are equal. So we just found that sine 90 minus theta is equal to cosine theta, or cosine 90 minus theta is equal to sine theta. Okay? We can also show that using this unit circle as well. So if you found the 60 degrees here, then you could get the same thing, right? Okay. But we would get that this is 1/2 and root 3 over 2. Okay. Anyways, any questions or any comments? Okay, I hope very good. Now we're going to talk something about the summation formulas. Again, if you write trigonometric formulas on Google, you will get obviously a bunch of the formulas, right? And you're going to memorize them. And we do provide those. But before we do that, so let's see here. Let's say that I have a rectangle, okay? ABCD, rectangle ABCD here. Okay, sorry, let me make it a little smaller. Okay. On the rectangle ABCD, then what happens is we take a point E, and then from E to BC, we draw a perpendicular line. Okay. And then you connect, let's call this point F. And here's a line here. Now, we are gonna find each of these line segments here in terms of the angles again. Okay. So let's say that we have an angle beta here. Okay. And let's say that DE is 1. Okay. I'm sorry, DF is 1. And I'm going to call this angle alpha. Now, we are going to find, like I said, each of these line segments in terms of alpha and beta. So let's start. First, I'm going to start with triangle DEF. On the triangle DEF, I'm going to write DE and EF in terms of sine and cosine beta part, right? So remember, sine beta is EF over DF. DF is 1. So that means EF would be what? Sine beta. Okay. Now cosine beta is DE over DF, adjacent over hypotenuse. And like I said, because DF is 1, DE is going to be cosine beta. Okay. Now, again, I find these segments, and we can find DA, AE, EB, and so on by using the beta and alpha here. Okay. Now let's start AD, and we can start by using the triangle AD. Obviously, there's a right angle, right? Now, if you look at the triangle ADF, ADE. Now, we can say that in triangle ADE, now we know that sine alpha is equal to what? Sine alpha is equal to AE over DE, right? Okay. And because sine alpha is AE over DE, and we know that DE is cosine beta, then AE is going to be what? Sine alpha times cosine beta. Okay. Now, cosine alpha is equal to AD over AE. Therefore, a DA is going to be cosine alpha times cosine beta. Okay. Let me write that here. Again, cosine alpha is AD over DE. From here, remember, we got that AE was sine alpha times cosine beta. And then here, AD was what? Cosine alpha times cosine beta. Okay. Now we are done with the triangle AD. Let's work on triangle BEF, right? But you can say, well, I don't know any of these angles. Well, let's see here. Actually, let's do a little bit of angle chasing. Here is 90 minus alpha, okay? And then you know that the angle BEF is equal to alpha. So then you know that here is 90. This part is 90 minus alpha, right? Remember, here is 90 minus beta. Then therefore, here is going to be what? Alpha plus beta. Okay. I hope that makes sense. Okay. Now, let's look at the triangle. So now we know all the angles, so we can figure out all the sides. Let's look at the triangle BEF. On triangle BEF now, I know that sine alpha is across from BF over EF, right? So we know that BF is going to be equal to sine alpha times sine beta. And then BE is going to be, well, we can guess that, right? Cosine alpha sine beta. Okay. So let's write it again. Sine alpha, cosine alpha sine beta. And then BF was sine alpha times sine beta, right? Okay. Now, finally, the last triangle is FCD, right? Now, if you use the triangle FCD here, write it here. Now, on the triangle FCD, I know that sine alpha plus beta, now this part here, right? Remember, guys, FC. Now, sine alpha plus beta is CD over DF, right? So therefore, CD is equal to what? Sine alpha. Let me write it here. CD is sine alpha times, sine alpha plus beta times 1, right? And we know that FC is equal to cosine alpha plus beta. Okay. Again, let me write it here. Cosine alpha plus beta. Now, we can see that ABCD, we are given that ABCD is a rectangle, right? Because ABCD is a rectangle, BC is equal to AD and AB is equal to CD. So using that, right, we know that AE plus EB is equal to CD, right? AE is sine alpha times cosine beta plus cosine alpha sine beta, which is equal to sine alpha plus beta. Okay. So there is one summation part that we need to memorize. And then the other part is AD is equal to BF plus FC, right? So we know that now from there, we can say that cosine alpha times cosine beta minus sine alpha times sine beta is equal to cosine alpha plus beta. Okay, this is the other formula. Now, using this, we can find, for example, the angle measure, like the angles cosine 15, sine 15, using 45, 30, and so on. Okay. Let's see, we're gonna do that, right? So let's see here. Now, let me write the formulas here again. I'm gonna copy that. Sine alpha plus beta is sine alpha, cosine beta plus cosine alpha, sine beta. And if this is minus, then the one that's also that part is also going to be minus. And then we have cosine alpha plus beta is cosine alpha times cosine beta minus sine alpha times sine beta. And if the sign is negative, then the sign between them is going to be positive. Okay. So this is very helpful because now we can figure out double angle formulas, and then we can find, like I said, sine 15 and so on. So let's see. First, let's start with double angle. Let's say that, let's find sine 2 alpha. Sine 2 alpha is sine alpha plus alpha. Plugging in here, we get the 2 times sine alpha cosine alpha, right? This is important. Another important identity. Again, how did I get that? Because sine alpha times cosine alpha plus cosine alpha times sine alpha. So that's why there's a 2. Similar, let's figure out cosine 2 alpha. This is a little bit different. So we have cosine alpha times cosine alpha minus sine alpha times sine alpha, with meaning it is cosine squared minus sine square alpha. Okay. Now, we also know that sine square is 1 minus cosine square, right? So therefore, this is equal to 2 cos square alpha minus 1. Or we can say that instead of cosine square, I can also write 1 minus sine square. So therefore, we can also get 1 minus 2 sine square alpha. So for cosine 2 alpha, we have 3 different ways to write it. Cosine square minus sine square, or 1 minus 2 sine square alpha, or 2 cos square alpha minus 1. And these are the important ones. We can also find the 3 alpha, the triple angle formulas. But because of the time being today, I'm not going to do that. But when we cover trig, we do find it. We find that it is cosine 3 alpha, sine 3 alpha, using the same identity. Now, with the tangent one, you know the tangent is sine over cosine. So we can also prove that. But let me write it. So tangent 2 alpha is, sorry, let me write the tangent summation first, then I can. So if I have tangent alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Okay. So if I plug in alpha instead of beta, we get the tangent 2 alpha is 2 tangent alpha over 1 minus tangent square alpha. Okay. These are the. We also cover the triple angle, but not okay. Okay. So far we looked at the function for the we looked at the how we write the ratios, right? We looked at the common angle ones, special angle ones. Then we define the side lengths using the alpha plus beta. This is especially important when we solve geometry questions. And then we find the summation formulas here. Here. Now, let's take a look at an example here. I'm sure that you've seen a lot of paper folding questions. So most paper folding questions, I mean, we use similarity, right? We keep track of the lengths, but we also, but we can also use trig, right? Because when you fold the paper, the angles will, like the length and the angles stay the same. Anyways, so first, for those who are, for those that are students or feel students in heart, yeah, I would like to give you some, like 1 minute or so to read the question and try it, and then I will go over them. I will go over the questions, okay? So again, but in the actual camp, we give like 2 minutes, but it doesn't exceed 3 minutes for a question. So I want you to just read it and attempt the problem, then we can go over. The question is simply asking us to find AC in terms of W and theta. Again, I hope you're trying. Again, we are given that AC is W, right? This is the width of the strip. If AC is W, what other length is a W here? Because remember, we fold the paper along AC to meet the opposite edge, right? Creating an angle theta. So if you fold it back, you can see that this is theta. What other length is theta here? If anyone knows, you can just simply write it in the chat box. I mean,
BD.
BD is, yes, thank you. BD is W, right? Because it is the same bond, you just fold it. So the length of AB in terms of theta, what we are going to do is we're going to write, you know that cosine theta is equal to AB over AC, adjacent over hypotenuse, right? So first, we know that AB is equal to W times cosine theta. BC is W times sine theta, right? So what about a triangle AEC? Well, what of a triangle AEC here? What? Is this a right triangle?
Yeah.
Yes, right. Do you guys agree that it's a right triangle? I hope it's okay. So, is everyone okay with that? It's a right triangle, right? Now, okay, thank you, Kevin. So we know that AEC is a right angle. Now, what is the length of EC and AE? EC is sine W times sine theta, right? What about the length of AE? This is W times cosine theta, right? Oops, I forgot C for cosine. Okay. I hope that makes sense. Now, again, right angle here. But again, the goal is to find the length of the crease AC. The width is W, right? Sorry, did I say that AC was the, sorry, the AC was not, we are going to find AC, right? So let me change it a little bit here really quickly. Sorry about that. Let me fix that really quickly. I thought I gave the AC as the W. Sorry about that, guys. Okay, so here is theta, right? So we are going to find AC in terms of W, right? The length of the, it says that the width of the strip is W, right? Okay. Are we good? W is basically the BD here, right? This is the length of the crease. That is not the folded part. Sorry about that. So this whole thing is W, right? BD. Now we can find, let's call that, again, let's call AC is X. If AC is X, then we know that AB, like I said, is equal to X times cosine theta. Then BC is X times sine theta, right? Then we know that for this is X times sine theta. Then we can also write the AE and EC in terms of X, right? We know that AE is equal to X times cosine theta, and EC is X times sine theta. Okay. Now, we know that here is 90 degrees. Then we can say that here is 90 minus theta, but we don't know any of these angles, right? Okay. So how can we figure out, because I need to find X in terms of W and theta, right? Okay. Now, we know that this angle here, angle BCA, here is 90 minus theta, right? Okay. Then we know that ECA, remember, because it is the folded part, let me do this really quickly. This is also 90 minus theta, right? Because of here is theta and theta. Okay. Remember, this part here was X times sine theta, right? And then we can say that this part here is equal to what? What is the angle ECD? That has to be 2 theta, right? Why? Because 90 minus theta, so here is 2 theta. Therefore, we can say that CED here is equal to 90 minus 2 theta. Okay. I hope that makes sense. Now, finally, because I know that BC is X times sine theta, therefore CD is going to be, what is the length of CD? W minus sine theta, right? Okay. Now I know that cosine 2 theta is equal to what? Now cosine 2 theta is going to be equal to W minus sine theta over X times sine theta. Okay. I hope that makes sense. And we also know that this is again X sine theta plus this is also equal to W, whatever we prefer. Okay. We can also write that, remember guys, so we know that here, right? We can say that cosine, let me write it this way as well, so you can see it. So we know that cosine 2 theta is equal to CD over X times sine theta, right? So we can also say that CD is going to be equal to, we can choose either way, or we are adding them, right? So CD is equal to what? X times sine theta times cosine 2 theta. Okay. Now, we know that this whole thing is W, right? X sine theta plus X times sine theta times cosine 2 theta, right? So let me write it here. Let's go on the left-hand side. So we know that W is equal to X times sine theta plus X times sine theta times cosine 2 theta. Okay. So therefore, X is equal to what? W over sine theta, parentheses 1 plus cosine 2 theta. Okay. Any questions here? So we found the length of AC in terms of W and sine theta, or I mean in terms of W and theta. But is there another way that we can write this? Or maybe like in these questions, sometimes if you have given multiple choices, we are given this in a different notation. So you should see if there is a way to manipulate this, okay? We know that cosine theta, okay, so this is cosine theta. So is there any way, is there a way to simplify the sine theta times 1 plus cosine 2 theta? Is there another version to write it? This is actually, I'm going to let this as an exercise. This is W over, we can rewrite this as sine 2 theta times cosine theta actually. Okay. This thing here is equal to sine 2 theta times cosine theta. Okay, this one is an exercise because you are getting close to 1248, okay? But both of them are correct. But sometimes, like I said in the choices, you might see this and you think you got it wrong. Need to see if there is a way to simplify, or vice versa. You get this, okay? So again, this is in the problems, they give you numbers. So they are telling you, they give you the angle, or they give you the length, and then you figure out certain lengths here. We just use the variables and we just found all the sides in terms of W and theta basically. Okay, so let's start. This is an easier example than the previous one. We are given a triangle, the side length, and find sine A, cosine A, tangent theta. So I'm sure this is easy for us, so let's move on to the next one. Okay. In the triangle, we are given angle B is 90 degrees, sine A is 5/7. So let me draw this, right? Okay, here is angle B, A and C. Sine A is 5/7. Okay, so if this is 5, here is 7. Again, we are not saying it's 5 and 7 because it's the ratio, it doesn't matter. The question is asking for the tangent, right? So all we are going to do is what? Find AB, and then we are done. When we know that AB is equal to square root of 24, I believe, right? So we know that tangent C is equal to what? Square root of 24/5, or 2√6/5. Oh, thank you, Nathan. Okay, again, simple enough, let's move on. Now, we are given a triangle, PQ is 3, QR is 5, PR is 6. Question is asking find cosine P and sine Q. To do that, this is actually an example from the geometry part. We are going to use law of cosines. Or if you are not, let's say, if you forget about law of cosines, in these questions, we are going to draw, let's say we draw P, Q, R, 3, 5, and 6. Then you are going to find the altitude, right? And then we are going to use summation formulas for this. But law of cosine is a lot easier to use in this case. But again, we learn law of cosine in the geometry part. Let's assume if you don't know law of cosines, then we are going to find altitude. There are two ways to find this. One is that we can find the area using heroes and find this, let's say this is point H, find PH, right? If you find, you know that the area of PQR can be found using heroes or base times height divided by 2, right? Okay. And then after we found PH, we can find the sine Q quite easily because we can find QH and HR. And then cosine P, we use the summation, sorry, they are not equal. We use the summation formula, okay? If you call this angle alpha and beta. Does anyone know what is the area using heroes? You use what? Semi-perimeter, right? What is the semi-perimeter here?
10.
7, right? So you do 7 times 4 times 2 times 1, okay? That's the area, right? Okay, so this is equal to 2√14. So the area is 2√14. Then we know that pH, or we can draw this altitude by using this one. That makes it easier. So let me draw it here. Then we can find, so first let's find the cosine P, right? So let's drop the altitude here. Okay, if you call this point K, then we know that's, okay, let's call this H sub Q. H sub Q times 6 divided by 2 is equal to 2√14. So H sub Q is going to be equal to 2√14 divided by 3. Okay, and then we are done, right? So we know that cosine P, cosine P is equal to, this cosine here is equal to pk over qp, right? Now we can find pk by using Pythagorean theorem, right? Okay. So again, I'm not going to go into details, so you can find again pk is square root of 4 times 14 over 9 minus 9 minus 4 times 14 over 9, right? Okay. And then we know QP, then we can figure that out. To find sine Q, you can, if you want, you can do the same thing, drop the altitudes. Or, like I said, we can use the summation formula. You find this, and then this angle here, you call alpha and beta, and go from there. Okay. But to me, it would be easier if you just drop the altitude and go from there. Okay. Just because of the time being, I'm not. Okay. And we're going to take a look at the next exercise. Okay. After, I will go through these exercises quickly. These are just sample questions, right? So, for example, in this one, the question is asking sine x, cosine x. For here, in these questions, if we divide both sides by cosine, then we get that here is 3. So therefore, tangent x is 3. When you know these values, the easiest way is just draw the triangle. ABC, let's call this angle x. Tangent x is 3. So 3 and 1, root 10. Then we are done, right? Because you know that sine x is 3 over root 10, cosine x is 1 over root 10. And if you multiply this, then we get what? 3 over 10, right? Is the answer. Okay. Next one. So for example, in this one, we are given the angle theta. We are given this random angle so that you don't know what the values are. Basically, the question is asking you to evaluate. Obviously, square this, sine squared theta plus cosine squared theta plus 2 sine theta cosine theta minus sine 2 theta. Sine squared plus cosine squared is 1. 2 sine theta cosine theta is sine 2 theta minus sine 2. So this is at 0. Okay. Does that make sense? Okay. Now let's take a look at these one. I want you to take a look at it really quickly, and then we are going to go over them, okay? I'm going to pick, so for example, I'm going to pick A, and then D and E. Now, this one here, remember guys, I said 2 pi is 360 degrees. So what is pi over 12 then? If 2 pi is 60 degrees, sine pi over 12, we are trying to find sine, thank you Kevin, sine 15, right? So to find sine 15, we can either draw the triangle and go from there, or you maybe memorize the ratios, but we can also use summation formulas, right? First, we know that sine 15, I can write it as sine 45 minus 30, okay? Or 60 minus 45, whichever is simple. So we know that this is equal to sine 45 times cosine 30 minus cosine 45 sine 30. So sine 45 was root 2 over 2. Cosine 30 is root 3 over 2. Cosine 45 is still root 2 over 2. Sine 30 is 1/2. So we can see that this is root 6 minus root 2 over 4. Okay. Now you can find cosine 15, it is root 6 plus root 2 over 4. Okay. And tangent, you just take the ratios. Now for part D, again, during the class, guys, during the summer camp, we go over them, just because of today's time being. Now, for part D, we are given cosine to the fourth and so on. When you see here, perfect square, difference, right? So that means we do what? Difference of squares. So we get cosine square pi over 24 minus plus sine square pi over 24, right? I'm sorry, other way around. Let me write this so that we can see it. You see that this is cosine minus sine, right? So when we find it, let me put a parenthesis, cosine square pi over 24 plus sine square pi over 24 times cosine square pi over 20 minus sine square pi over 24. Now we know that cosine square plus sine square is 1. Now on this one, this looks like difference of, this is the, although you can say, well, I can write this as difference of squares again. But notice that this should remind you of cosine double angle formula for cosine, right? So this is cosine pi over 12 actually, right? Which is equal to root 6 plus root 2 over 4. Sorry, I wrote it horribly. For the question here, for part E, this one here, it is easier to use the triangle, meaning that we're going to use, let's say we have 72, 72, and then what is this angle going to be? 36, right? And then we draw the angle bisector here. Okay. And then we get the 36, 36, right? So you know that here is 72 as well. And then, again, our time is almost up, so and then we can draw the altitude here, right? Or we can drop the altitude here. Now we're going to use angle bisector to find the values. Okay. But for now, I'm going to stop here. Like I said, this is just to give you a basic idea of how we solve the questions. Obviously, the easier questions, for example, like these ones, we just did really quickly, and then we have a lot harder. For example, in this part here, E is pretty challenging. Okay. Any questions about the problems that we just solved? If not, let me go over the class sequence. Give me 1 second here. Excuse me, give me 1 second, please. There we go. You should be able to see it now. So we have so the momentum learning, we have at momentum learning, we offer classes in contest math and also computer science, English. So on every year, we have, from our contest math courses, we have more than, each year we have more than 200 students qualifies for the distinguished honor roll in AMC8. And we have about 15 to 20 students who get a perfect score in AMC8. And we have about 60 JMO qualifiers, and we have somewhere between 4 to 8 students who qualified for MOP, okay, the Math Olympiad Summer Program. And so here is our curriculum. So this is the timeline. The green part that you see is our fall and spring courses. So we start with Contest Math 100, and it goes all the way to 701 and 702. Our 600, 601 and 701 coded courses, they're a 2-year-long course. And then this year we are adding Contest Math 600 and students. So, and then for the summer, so you can see that students who are in Contest Math 500, 501 are recommended to take level 2. Some 501 students, okay, they take level 3. But for level 3, we are looking for JMO index of 180, more than 180. JMO index is your AMC score plus 10 times your AIME score. And if you're in 401, you might qualify to take level 2, depending, you either take a test or the teacher recommendation or your AMC 10 score from the recent year. Okay. And so if you're not sure again which level to take, you are more than welcome to contact us, and then we will give you a recommendation depending on your scores or depending on the test that you took with us. It is important to choose the right level, because if the level is too easy for you, then it's basically you're wasting time. But more than that, we get students would like to take higher core level than what their current level is. But that creates a problem, that because after a few courses, students choose either not to attend because they find it's too difficult, and also or we don't get, or they don't ask, they stop asking questions, and they just basically give up on the course, and which is not a good experience. And it is also not good use of time and the money, obviously. And here's our summer camp. So the level 2, we have this is the online one, and we have the one from June 6 through 17, June 20 through July 1st, and then we go from July 25th through August 8th, and July 11th through July 22. For the geometry and combinatorics, we cover starting the late June, and then in the first session we covered algebra and number theory. They again, for our last 2 weeks in June is also offering in person. And the topics and the sample questions you can find it on our website. If you paid by April 15, we get a 5% discount. And if you register for all day courses, there's a $100 additional discount. And if you go to our website, if you click on the online contest Math Summer Camp, easily be seen there. Any questions? We also have USACO camps. You can find it on our website. So any questions? I know we are 5 minutes past. Anyone has any question regarding the camps or?
I have a quick question. So if the student take the level 1 summer camp,
yes.
Can he directly go to enroll in the course 500 in the fall semester?
So it depends on, so we will look at how they perform in our level 1 camp, and depending on, like I said, like if they participate, we give some assessments during the camp as well, then we look at that. But or you can also take the test. We have a test, but the test is usually between 401 and 501. But we can also, looking at which questions they missed, we can also look at it if they would be good fit for 500.
Got it. Yeah, thank you, Michelle.
No problem. Any other questions?
So isn't there some grade limit for 500? Like you can't be in 500 if you're under some grade?
So for 500, we recommend it, for example, if you're in 6th grade, because 500 is not necessarily harder than 401. 500 is the topics are different, but so we recommend the 6th graders, for example, or the 7th graders to take 401. And but sometimes there is like a day conflict or so on, so that is understandable. But we usually we reserve 500 for those who are in 8th grade and high school who did not qualified for, or who didn't qualify for AIME. So because the topics are a little different than 401. For middle school students, 401 is still our recommendation.
Well, right now I'm only on 5th.
When you're in 5th, then yeah, 401 would be the way to go.
Well, 401 seems to be probably too easy. I think that level 2 is good.
So it isn't, like I said, 500 is not necessarily harder than 401. Any other questions or? If you don't have any questions, I thank you so much for joining today's session. You can always email us at info@momentumlearning.org. If you have questions for me, then my email address is inal@momentumlearning.org. And we'll be happy to answer any questions you might have. And thank you so much. Bye, everyone.